Hello, this is Mrs. Taylor, and I'm going to demonstrate for you how to expand a binomial using Pascal's triangle. In this problem, we are asked to expand completely, and our binomial is 3y minus 4x, so it's all raised to the fourth power. So what we learned in class is instead of multiplying this out, doing 3y minus 4x times 3y minus 4x times 3y minus 4x times 3y minus 4x, we can use Pascal's triangle as a shortcut to go directly to the polynomial that would result from multiplying all that out. So first thing we need is Pascal's triangle, and it looks like this, and the pattern is that it always starts with 1 at the top and then another set of 1s in the next row, and then you add the two numbers together to get the number below it in the next row. So 1 plus 1 is 2, and you always begin and end a row with 1. So 1 plus 2 is 3, 2 plus 1 is 3, end the rows with 1s, and then you have 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, end with 1s, and so on down the line. And these rows represent the coefficients of polynomials when you expand binomials. So if I expanded, or if I raised a binomial to the 0 power, that would be represented by this first row. My coefficient would just be 1. And then to the first power would be the second row, to the second power would be the third row, all the way down. Now, if I'm raising it to the fourth power, that would be the fifth row of Pascal's triangle, or the row that starts with 1, 4. That corresponds to the coefficients that I would get if I multiplied this out. So those are the numbers I will use as my coefficients for my polynomial once I expand. Now, the way I write this out, and the way I've shown you in class, is I'm going to write out these coefficients and give space between them, because I know I'm also going to have some variables and things like that that I have to work with. So to start with, we'll do that. 1, and then 4, 6, 4, and 1. And then I'm also going to include my plus signs. So a plus sign here, there, and there. And I just need to clean this up a little bit. There, on a nice line. Okay, the next thing I have to do to finish my polynomial that I would get as a result of multiplying this all out is I have to work with the first and the second term in my binomial. And so there's a specific pattern that we noticed in class. And that pattern is that this first term in my polynomial is going to be raised to the power of the original binomial. So in other words, 3y will be raised to the fourth power for this first term in my polynomial. And then for each term after that, the exponent goes down by 1. So in this first term, I'd have 3y to the fourth, and then 3y to the third, to the second, to the first, and then to the 0. So let me enter that in. All right, so just to repeat that pattern, our first term in our binomial for the first term of the polynomial will be raised to the same exponent as your original. And then your exponent goes down by 1 for each subsequent term. So 3y to the fourth, third, second, first, and then 0. Now, your second term in your binomial goes in the reverse. So instead of starting to the fourth power here, it starts at the 0 power, and it goes up by 1 each time. So I'd have negative 4x to the 0 power, to the first, second, third, and fourth. And just a note, keep in mind that this subtraction means that there's a negative that travels with this 4. So when I put it in parentheses for my polynomial, I include that negative. So when I write that out, it would look like this. you would have negative 4x all to the 0 power, and then to the first, second, third, and then fourth. So after you write it all out, it looks a bit overwhelming, but piecing it together wasn't actually all that difficult. Now the next thing I have to do is simplify. I need to go ahead and evaluate what I can with the exponents and then multiply everything together for every single term. And so the order of operations says parentheses, then exponents, then you multiply. And so what I have to do is I have to evaluate these exponents before I can multiply anything out. And so for the first term, I have this 1, and then I have a 3 that I need to raise to the 4th power. And then I need to raise this entire thing here to the 0 power, which is pretty simple because anything raised to 0 power is just going to be 1. And then the y here will be raised to the 4th power as well. So 3 to the 4th power is 81. This would be y to the 4th, and then this entire negative 4x would simplify to 1 because I raised it to the first power. So the result would look like this. I would have 1 times 81 times y to the 4th times 1. And then to fully simplify, I would multiply all these numbers, the 1, 81, and the 1. Of course, when I multiply all that out, I just get 81. So my final simplified term would just be 81 y to the 4th. And I just repeat that process down the line. So here I have 4, and then I would go ahead and evaluate 3 to the 3rd, and this would become y to the 3rd, and then evaluate negative 4 to the 1st and x to the 1st. So once I multiply all that, it would look like this. I would have 4 times 27 times y cubed times negative 4 times x. And so what I would do to simplify is I would multiply the 4 times the 27 times the negative 4, and that would give me negative 432, and then I would just put my variables at the end, the y cubed and the x. So the final simplified form of this term would look like this, minus 432xy cubed. And I would just continue that process down the line. And so you don't necessarily have to write out this step here in your work. I just wrote it out to show you how these rules of exponents would look once you evaluate it. So I'm going to go ahead and work out the last 3 terms and write out the result here. So after I evaluate the exponents, multiply all my coefficients together, the resulting polynomial would be this, 81y to the 4th minus 432xy cubed plus 864x squared y squared minus 768x cubed y plus 256x to the 4th. And so that is how you would use Pascal's triangle to expand a binomial.